Hello, everybody. Today we are going to solve the CBA 12 review questions. And the topic is irrational expressions, addition, subtraction, multiplication, division, and of course, simplification, and of course, the equations of them. So let's start. Which of the following statements is false about the graph of the function y is 8 over 3x? So what kind of graph they are, guys? Usually we have this kind of graph, right? And as you see, domain and the range, it is false. The domain is all real numbers except 0. This is true. Domain is all real numbers except 0. 8, 0 has no value. The graph has one vertical asymptote and one horizontal asymptote. This is the horizontal asymptote, and this one is the vertical. And yes, it is correct. The range is all real numbers. Range, as you know, the y values of the function, set of function values. But here you see y values on the y-axis, we see 0. When y is equal to 0, there is no x value. It means 0 is out of range, so this is false. Number 2, which of the following statement is false? Again, so now we have 2 over 2 plus x. What does it mean 2 over 2 plus x? So here we know that denominator must be different than 0, right? And here we say x cannot be negative 2. X cannot be negative 2. If we see the graph, so we have a vertical asymptote at negative 2. Okay, guys. And let's see what is the value of the function at 0. If x is equal to 0, y is equal to 1. Here it is, right? So this is the general type, general shape. It's like this. So the graph will be like this. It's not necessary to draw the graph for this function, but I just want to show it. So, is there any x-intercept? X-intercept? No, there is no x-intercept here. Y-intercept is 0, 1. It's true. X is minus 2 is the vertical asymptote. Here it is, true. Y is 0 is the horizontal asymptote. Here it is, true. So this is the false one. Number 3. How is the graph of y is 1 over x minus 2 different from the parent function y is 1 over x? Okay, so in 2 ways we can find this one. First, we can find the domain and the vertical asymptote. Here the vertical asymptote is 0, right? Like in question 1. But here x minus 2, and we know that the denominator must be different than 0. It means x must be different than 2. So we have the vertical asymptote at 2. Okay, and also we know this is the first thing, right? So vertical asymptote was at x is 0. Now x is 2. It means it's shifted 2 units right. The parent function is shifted 2 units right. So this is the correct thing. Answer. Also, we can understand from here, you know, whenever we have a number with x, we shift the parent function graph to the left or right. So here x minus 2, it means we shift the parent function 2 units right. Okay, so it will look like this. And if x is equal to 0, it means 1 over minus 2, where x is equal to 0, y is negative 0.5. So guys, the graph will be like this. Is everything okay? Number 4. Number 4, the sum of the reciprocals of 2 consecutive even integers is 11 over 60. Which equation can be used to find the 2 integers? It's good one because it doesn't ask those numbers, those integers. It asks the equation. So here use x1, the consecutive even integers. How can I show them, guys? Consecutive even integers. If the first integer x, the second integer should be x plus 2, right? The first even integer and the second even integer. So since here we have x and x plus 2, I use these numbers. And the sum of the reciprocals. So I have 1 over x and 1 over x plus 2 is 11 over 60. So this is the equation basically. Do we have it here? Yep, here it is. This is the answer. Number 5. Suppose that x and y are very inversely. All right, so we have inverse variation also. And what was it, guys? Let's remember. Inverse. When we have inverse, we have y equals k over x. Okay, so very inversely. Okay, if we have direct variation, how was it? It was y equals kx. What was the idea? So k is the constant. When x increasing, if x increase, let's say, since k is constant, y must increase. You see, y and x increase together, decrease together. So this is direct. Inverse, very direct variation, inverse variation. In inverse variation, since k is constant, if x increase, this number doesn't change. X gets bigger, so y gets smaller, right? So inversely, they are changing. All right. Suppose that x and y vary inversely, and x is 40. So we can use this one. Just this. Y is k over x. Okay. Y is k over x. And given numbers, x and y value given, we use them to find k, the constant, variation constant. Okay. So y is 16, k over 40. So from here, guys, what is k? K is 16 times 40. Okay. Hey, I don't multiply it because most probably I will have simplification. What is y? Now I write it again. Okay, now I use the red color. Y, so again I use this one, k over x. But k, I know 16 times 40. 16 times 40. When x is 32, and I write 32 for x. And you see here, I can simplify 13 and 62, 2 and 1, and 40 over 2, y equals 20. This is the answer. What function models the inverse variation? What function models the inverse variation? What is y? Oh, okay. So what is y when x is 32? It's the y is 20. And there is a second question. What function models the inverse variation? So it's important the y and x are variables. It's important to write the k, and it will be y equals, in this case, I can write the value 16 times 40, 640 over x. This is, yep. I hope it is clear. Number 6. Suppose that a and b vary inversely, and b is, so here we have a and b. Okay. So let me solve it here. B and A values are given. Okay. A and B vary, so let's write it as B is K over A. All right. And B is 5 over 12 equals K over A is 2. All right. So I need to find K first. How can I do that? I can make cross multiplication. So 10 equals 12K. And from here, K is 10 over 12. And okay, I keep it 10 over 12 to make a simplification. Write a function that models the inverse variation and find B when A is 10. So in this case, the function is B, not Y. It's given because A and B. B equals K over A, right? So K is 10 over 12. Okay, I write it 10 over 12 over A. And what does it mean, guys? I can simplify 10 over 12. It is 5 over 6. So 5 over 6A. B equals 5 over 6A. This is the model. And find B when A is 10. When A is 10. So B is equal to 5 over 6. A is 10. And from here, if I simplify, I have what? B is 1 over 12. B is 1 over 12. So what we've found, the function models the inverse variation and the B value for and when B A is 10. Okay. A drama club is planning a bus trip to New York City. The table represents the cost C per person for the bus rental compared to the number of people N. So number of students, cost per student. As you see, more people, less money. Okay, what equation models the data? So here, what we have, inverse or direct variation, okay? We should see, so when the N increase, but the cost decrease. So this should be the inverse variation. How we were doing, guys? We should find the constant for every data, okay? So we have Y is K over X. We need to find the K, okay? And here, as you see, from here, K is equal to Y times X in inverse variation, if I make cross product. So for each situation, if I multiply them, I can find K and I can choose the accurate one. 27 times 4, it's 108. 18 times 6, 108. 8 times 13.5. 8 times 13.5, what it makes, guys? So 80. Yeah, it's 108. What is this? Okay. And 9 times 12, it is 108. Good. All in every situation, we have the same constant. So it asks the equation Y equals K over X. This equation models the data. Well, only the thing I can change here, since it is given with C and A, so I change it to so C is equal to 108 over X. Okay. Number 8. A soccer team is collecting money to buy their coach a present. The table represents the cost per person for the gift. compared to the number of people contributing. What function models the data and how much per person will it cost if all 40 players contribute? Good job. So here again, number of players increasing and the cost per player decrease. We have to find the constant by product. So 5 times 40, 200. 8 times 25, 200. 15 times 13, so this is 195, right guys? 15, yep. And 20 times 10, it's 200 again. So we have this value, but remember, since the difference is too small and this is the real life situation, we can ignore this and we can select the most repeated number, which is 200. So K is 200. What function models here? The data and how much per person. We will have, so C is equal to 200 over K. Not K, sorry, N. C equals 200 over N. This is the function model, and the cost for if all 40 players contributed, it means number of players 40, C will be equal to 200 over 40, which is 5. The cost will be $5 per player if all will contribute. Number 9. Suppose that y varies directly with x and inversely with z. Okay, so how we write this? Attention. So y equals directly with x. In direct variation, we were using y equals kx. Okay, so this is combining 1. So we have kx directly with x and inversely with z. So then y k over z. We write it together. Given the y, x, and z values, we use them and we find the k. Y is 28. I'm looking for k. X is 32. And z is 8. Okay. So from here, I need to find k. I can simplify them. Here I have 4. K is 28 divided by 4, which is 7. Okay, guys, K is 7. The constant of this direct or inverse variation. And then find the y when x is 12 and z is 3. Okay. Y equals K is 7. X is 12 and z is 3. KXZ. From here, I have 4, 1, y equals 28. As you see, x is 12, z is 3, again it's 20. Good. Yes, it's correct. So we have, maybe I write it here, y equals 7x over z. This is the equation, and this is the y value. Number 10, write an equation for the translation of y is 4 over x. So this kind of question, similar one we have solved, right? On this page, I just talk about some. That the asymptotes x is 7 and y equals 6. So guys, y equals those asymptotes about what? If you look at here, the root of the denominator actually gives the vertical asymptote, right? So here, what we are going to do, since the x is 7, so I will have 4 over x minus 7. It means 7 is vertical asymptote, okay? And y is equal to 6, it means plus 6, okay? That's it. These are the, when there is nothing, here we have x is equal to 0, y is equal to 0, the asymptotes. The vertical asymptote change up to denominator, and we know it shifts up since the horizontal asymptote y is equal to 6, this is, right? So x is 7, y is equal to 6. It is like shifted 7 units right, so x minus 7, and shifted 6 units up, plus 6. Make sense? This is the answer. Number 11, if a parent function is 1 over x, it's stretched vertically by a factor of 3. Stretched vertically by a factor of 3. Okay, if it's vertically, we have this one. It should be like this, a times f of x, as you remember, right? What would be the equation of transformed function g of x? If the factor of 3, we will have the function 3 over x. And is there a function g of x? Okay, this is g of x. G of x is 3 over x. Is it clear? Number 12, and started rational expressions. Wow. Number 12. So we have to be the master of factorization here, guys, okay? Vertical asymptotes of the graph. So how we were finding the vertical asymptotes of the graph? So the roots of the denominator gives the vertical asymptotes, right? Basically. And this is number 12. Here already we have factors in denominator, the zeros. Let me write here. Zeros of denominator are vertical asymptotes. So how do you find the zeros? I write them each equal to 0. So x plus 5 is 0. From here, x is negative 5. X minus 4 is 0. From here, x is 4. These are the vertical asymptotes. These are not in domain. Attention, okay, it's different. So this function, if we see the graph, if we draw the graph, this function will have no value at minus 5 and at 4. Okay. All right. And number 13, horizontal asymptotes, guys, what was it? So vertical asymptotes, the zeros of denominator, and the horizontal asymptotes, if the degrees are equal, we take the coefficients as horizontal asymptote. So here, the horizontal asymptote is, since it is horizontal, we have y is equal to 5 over 4, okay? Horizontal asymptote. So here, number 14, remember, we check the degrees, not the coefficients, degrees of the leading terms, numerator and denominator. Here, square, square, so we take the coefficients, okay? Here, it's cube and square. In this case, if the numerator's degree bigger, we say no horizontal asymptotes, okay? And here, number 15, if the degree of denominator bigger, you see 4 greater than 3. So here the horizontal asymptote is 0. Okay. Number 15, right. And number 16, you go there. Simplify the rational expressions. All right, let's find the factors. So we have k, k. I'm looking for two numbers. Product gives 12 and the sum gives 7, 4 and 3. Okay. And in numerator, I look for two numbers. The product gives 21 and the sum gives -4. I can write -7 and +3. Yes. -21, -4. Yes. And how do we simplify, guys? K plus 3s I can simplify because they are in product. I can simplify only the factors. Pay attention. I cannot simplify the coefficients. This K and this K I cannot simplify. I cannot simplify the constants, like, for example, these two numbers only separately. I cannot simplify. I can simplify only the factors. And here it's K minus 7 over K plus 4. This is the simplest. Number 17, simplify again. So let me continue here. T squared minus 4t minus 32. I have t. So I'm looking for two numbers. Here I have t minus 8, right? Product is 32. The sum is -4. 4 times 8. Since the sum is -4, -8 plus 4. And I can simplify these factors. T plus 4 is the answer. Number 18, what is the product in simplest form? Well, I have to simplify and the numbers and the variables. So you see 2 and 2 simplified. 8 and 3 remained, and I cannot simplify them. So I have to carry to the answer. K cubed and K fifth power. If we simplify, so we will have K squared in denominator and J to the 6, J squared, I will have J to the power of 4. This is the simplest form of the given. No, actually not the simplest. This is the result of the multiplication. Number 19, simplify. Okay, so it's multiplication. I see the y plus 5 is the factor here. Y squared plus 3y. So let me write it again all together. Okay, so I have y plus 5 in denominator. Also, the common factor here in these two terms is y. So times y plus 3 I can write. Y times y is y squared. Y times 3 is 3y. Okay, and here multiplication, okay, but I don't multiply. It doesn't help me. I need to find the factors. So how can I factorize this? Y, okay? Well, I need two numbers. Product is 30 and the sum is 11. They are 5 and 6. Yep. Y plus 5 and y plus 6. So I have y squared. It comes from the first fraction. Y plus 5 times y plus 6. Now I have all the factors. Attention, it's simplification question. I don't multiply. I need to split as possible as many as possible factors, okay? And then I simplify them. So what do you see? Y plus 5 and y plus 5. On the other hand, y and here this one, because there are two y's, y times y, one of them will be canceled with this y. Can I simplify y plus 6 and y plus 3? Hey, I can simplify 6 and 3 here, right, guys? No, pay attention, no, because 6 and 3 I cannot simplify. I can simplify only the factors. The factor is y plus 6. The factor is y plus 3. So I cannot simplify. I have y times y plus 6 over y plus 3. Here we should add the explicit points. So y cannot be what? Even we don't have y plus 5 in the final answer, right? We have to write those numbers from the original question. So y plus 5 here. So y can be negative 5. Y must be different than negative 5 because it makes denominator 0. I have to write like this. Y is different than, this is the domain actually, right? Y is different than negative 5. And here, this is the factors of second fraction. Y cannot be 0 and y cannot be negative 3. Is it clear? This is for question 90. Okay, question number 20. Simplify. So we have to find the factors and then simplify the factors. Oh, this is 4th degree. It is nice, but it is 4th degree. This is 2nd degree. Okay. So how we were doing here, we had square, 2 and 1, 4 and 2. We are following the same way. It's nothing strange here. So here, what we were doing, y times y makes y square. Yes, guys. And here we have y. And how do we get n to the power of 4? If I multiply n squared times n squared, and here I have n squared. Good. And now I look for two numbers. Product must give 18 and sum must give -9. What are they? -3 and -6. Do you agree? -6 times -3 is +18 and their sum is -9. You see, I write it like quadratic. And here, again, since n to the power of 4 and n squared, this is n to the n squared, I'm sorry, and n squared. Okay, two numbers, product must give 24 and the sum -10. They are 12 and 2. Since it's negative, the bigger number I write with negative. So -12 times, oh, -12 plus 2, it doesn't work. This is +24. My bad. Let's change the guys. So what numbers are they? N squared. Since here minus, both should be minus, guys, okay? Because here plus, both should be minus. They are 4 and 6. N squared minus 4 and n squared minus 6. What do you see? These are the common factors. I can simplify. And I have to check if also these can be factorized, right? But n squared minus 4, you know, there is one thing you always have to remember, but unfortunately, many of you always forget. This can be written as n minus 2 times n plus 2, since 4 is 2 squared. Okay. So, but we have n minus 2, n plus 2. This is n squared minus 3. No, because I will have n minus square root of 3 and n plus square root of 3. No common factors. It means this is the simplest form of the given expression. Number 21, multiplication, oh, division here we have. So we know what to do. Here, there is nothing to do in the first fraction. I have w plus 1 times over w minus 3. And if I have a division, I multiply by the reciprocal of the second fraction, right, guys? So here I will have w plus 5. And I just write here the factors of the w squared plus w minus 12, which is, so two numbers, product is negative 12, and the sum is plus w, so that is plus 4 minus 3. Okay, now, what I can simplify? Well, w minus 3 is a factor. There is nothing else. This is it. So w plus 1 times w plus 4 all over w plus 5. This is the final answer. Okay. Last page. Simplify, 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 simplify. And here 5 questions, the equation questions. Here the sum, okay? So how we wording the sum? We must have common factors in denominator, right? So let me rewrite this with the factors. 4y plus 16, this actually can be written as 4 times y plus 4, okay? So guys, 4 times y plus 4, y plus 4, y plus 4, common factor already. So, but here in the first fraction, I have 4. In the second fraction, I do not. In addition, I must have all the fractions, actually, not all the fractions have the same denominators. And so I multiply the second one by 4. And I rewrite the question here again. So y over 4 times y plus 4 plus, when I multiply this by 4, I will have here 4. You see, I multiply by 4 now, the whole second fraction, and it is y plus 4. You see, now 4 times y plus 4, 4 times y plus 4. Attention, I multiply and numerator and denominator by the same number, so I didn't change the given value of the question. I didn't change the question. And then we have y plus 4. Since this is the common denominator, I write it once, 4 times y plus 4. Did we finish? No, because now we have one fraction and we can simplify it, right? Simplify what? Attention, this is the whole thing is a factor, so I can simplify it. I cannot simplify 4 or y separately, but together I can. And the final answer is 1/4. Okay. It is number 22. Now, number 23, simplify the sum. Basically, we did how we made the sum and then we simplified. So we have to find the common denominators first. Here we have to factorize the denominator. Let's do it. 21 are 7 and 3, right, guys? And here, since plus 4, that the big number is positive, plus 7 minus 3. Okay, what about numerator? I also factorize this one. And by the way, you see, c minus 3 already both fractions have. C minus 3 is a common factor. It means I have to multiply the first one by c plus 7. Okay. Well, then, do I need to? No, I don't need to factorize this at this step. I continue. So I multiply. Okay. Equals c squared plus 5c minus 40. The common denominator right here, guys, okay? C plus 7 times c minus 3. And I multiply 5 by c plus 7. So plus 5 times c plus 7. Okay. This will be better. And right. Let's combine here. The common denominator is same, c plus 7 times c minus 3. C squared. So since I don't have much place, I will combine here, guys. 5c plus 5c. I will have plus 10c. And minus 14 plus 5 times 7. 5 times 7, 35. Plus 35 minus 14, it is plus 21. Okay. And it looks like I will solve it 24 in another paper, no problem. Here I can factorize the numerator now. 21 and 10. Product of two numbers 21. The sum of two numbers 10, they are 7 and 3. So I will have c plus 7 times c plus 3. And in denominator, I have c plus 7 times c minus 3. The common factors are c plus 7 and the final answer c plus 3 over c minus 3. Okay. 24. Okay, solve it here, guys. Number 24. Simplify the difference. So the logic is same. The denominators must be common. So I don't need to factorize the numerator yet, but the denominator, I can factorize it here at least. Z. So negative 12, product of two numbers 12, the sum minus 1, that is negative 4 plus 3. Okay. So I rewrite the question. Z squared minus 7z plus 12 over z minus 4 times z plus 3 minus 2 over z plus 3. What do you see? Z plus 3 common factor. So I have to multiply the second fraction by z minus 4. Z minus 4 and denominator I multiply by z minus 4. And okay, now I have the common denominator equals common denominator I write here just once. Z minus 4, z plus 2. So here I have z squared. Now guys, minus 7z minus 2z. Together minus 9z. Plus 12 minus 2 times negative 4. Pay attention. 12 minus 2 times negative 4. What is it? Negative 2 times negative 4 is positive 8, and plus 12 is plus 20. Okay, actually we have finished the subtraction operation. Now I have to look for simplification. I have to now factor the new numerator. That is z. So 20, 10 times 2, does it work? 10 to 9, no. So 4 times 5. Since it's positive, it's negative. Both should be negative. And 4 and 5. Negative 4 times negative 5 is positive 20, and their sum is negative 9. In denominator, z minus 4 times z plus 3. You see, we can simplify the factor z minus 4, and the final answer is z minus 5 over z plus 3. Yes, guys, that's it. It was number 24. Number 25, simplify the complex fraction and state any restrictions on the variables. I think I will use the back side of this paper. Okay. Well, here I have subtraction. I perform that. In denominator, I have addition. I perform that. And then I will simplify the factors. So what is the common denominator here, guys? In numerator, common denominator here. Okay. So what we do, this is 4 times x, and this is 5 times x. Pay attention. Both fractions have already have x. That's it. So I don't have any job with x. Goodbye x. So, but here, the first fraction has 4 and the second one has 5. Okay, they don't have common factors. It means I have to multiply the first fraction by 5 and it will be 20x. And I have to multiply the second fraction by 4 and it will be 20. Okay, so I multiply this by 5, the first one, and the second one I multiply by 4. Make sense? And what do I have? I have 15 over 20x minus 8 over 20x over. So the same logic in denominator, guys, here. 2 denominators, 3x and 5x. Both have x. Goodbye x. I don't have any job with you. And now check the numbers, 3 and 5. 3 and 5, they don't have any common factor between them. So I have to multiply the first one by 5. Okay. And the second one by 3. So this I multiply by the other. So this I multiply by the other. Okay. And I have, let's have it here, 5 over 15x plus 3 over 15x. So what do I have? Now, 15 minus 8 is 7, and the denominator is 20x in numerator. And 5 plus 3 is 8 over the denominator is 15x. This is the division actually, right? What should I do? I have to, so look, this is one fraction, this is another fraction, we have division between them. So I can write it like 7 over 20x divided by 8 over 15x, and it helps me to figure out easily, because when it is in this form, oh, I know what to do. I multiply the reciprocal of the second fraction, right? And so I write it here. I have 7 over 20x times 15x over 8. So the x is simplified. 7 and 8 I cannot simplify. 15 and 20 I simplify. If I divide by 5, here I have 3. It's 3 times 5. This is 2 times 5. So 5's cancelled. 3 and 4. Okay, that's it. So 7 times 3, it's 21. 4 times 8 is 32. Okay, there is no other simplification here. And we finished the simplification problems. Now the equation. So in equation, as you see, we didn't have any equal sign on these questions. Just the addition or subtraction, or here we have the product or division of them. But now we have equal to. They are given equal to something. It means we have to find, or not this two, in these three, equal to. These three questions are equation questions. We have to find the variable. Check your solution for reasonable state and restrictions. Restrictions are the zeros of denominator, don't forget, okay? And the first step, since we have addition, I have to combine them. Addition, equal denominators I must have. And the denominators here, guys, a squared minus 16, a minus 4 times a plus 4, all right? And so I write here, so the second one is a minus 4, okay? So this is a minus 4. Here we have to pay attention to that one. Common denominator must have all the fractions on the left side or on the right side of the equations, okay? So there are two ways here. So as I did before, I can multiply each fraction by the necessary factor. So for the second one, I need a plus 4. So I multiply this by a plus 4. And the fraction on the right hand side, we need a minus 4. So I multiply it, numerator and denominator, by a minus 4. Okay, this is the first way. And I show the second other way in other question. Okay, so what do I have? I have a plus 2 times a plus 4. That is 2a and 8. 2a plus 8. The common denominator on the left side, a minus 4 times a plus 4, equals a minus 4 times a plus 4 times a minus 4. As you see, I don't multiply them and I don't simplify. My aim is not to simplify here, okay? It was simplified for, but I multiplied to get equal denominators. Now, attention. When we have equal denominators on both sides, we just ignore them. How to explain this? We have a fraction on the left side, we have a fraction on the right side. Now their denominators equal. These are equal. It means, and their numerators must be equal to each other. Okay, so I have to write equal them. So I just kind of ignore the denominators. Okay, but from here, what is important? Restrictions. Okay, so denominators are important for the restrictions because we know denominator cannot be 0, right? So a minus 4 must be different than 0, and a plus 4 must be different than 0. It means a must be different than 4 and negative 4. This is important. We have to have in every rational expression equations, rational equations questions, okay? And then, so I said, now we have one combined fraction on the left side, one combined fraction on the right side. Their denominators are equal, so their numerators must be equal to each other. And I write them. A plus 2a plus 8 equals a minus 4. Okay, yes, there is no a square. I could add them, right? 3a. Okay. And well, I just combine them. I will find a, guys. So 3a plus 8 equals a minus 4. If I combine the a's on one side, subtract a on both sides, I will have 2a plus 8 equals negative 4. 2a equals, if I subtract negative a from both sides, 2a equals negative 12, and a is equal to, I divide both sides by 2, it's negative 6. A is negative 6, a different than 4, and negative 4. Is it true? So a is negative 6. So negative 6 squared is, what guys? 36. 36 minus 16, it's 20, right? So let me write here. Let's take the answer here. So negative 6 over 20 plus 2 over a minus 4. Negative 6 minus 4 is negative 10. Is it equal to 1 over a plus 4? So negative 6 plus 4 is negative 2. Is it possible? Let's check it out. Well, I can simplify this and I will have negative 3 over 10. Negative 2 over 10. It is negative 1 over 2. Is it true? Negative 3, negative 2, it's negative 5 over 10. Is it negative 1/2? Yes. So really, a is equal to negative 6. Okay. So we have to check. If it's a free response question, you have to check the answer. And in some questions, we already have error restrictions and we may have the same number as answer, but we cannot take it as an answer, right? Even a, we got a is, let's say 4, but we cannot take it 4 since it is a restriction. It is the 0 of denominator. It cannot be never the solution. Number 27. So let's separate it to it, okay? On the left side, the common denominator is 9x, right guys? 9 and x. So let's have it by 9x. Okay, so here there's a question. Let's find the least common denominator here, guys, right? So number 28, I will show that method here. I solved the previous one, I solved this one like that. We have 3x times and 9. So the common denominator here, 9x, I multiply the first fraction by 3 and the second one by x, okay? And on the right hand side, common denominator is 36x. This is the least common multiple of 12 and 18, okay? So I multiply this by 3 times 3 times 3, and this one multiplied by 2x, by 2x. So I have what? 3 over, actually 3 plus 7x over 9x. Now it's equal to 15 plus 22x over 36x, okay? Now it's much more clear. So 9x, 36x, still my aim to get common denominators, make the denominators equal. I multiply the first one by 4, the first one, the fraction on the left side. So I have 12 plus 28x over 36x equals 15 plus 22x over 36x. Yes, guys. And here, fractions are equal, denominators are equal. We ignore the denominators, but we have to write x must be different than 0, the 0 of the denominator. And then I write the numerators equal to each other, and I solve it for x. Oh, sorry, 15 plus 22x. X is on one side. I have 6x on the left hand side. 15 minus 12 is 3. So x is 1/2. X is different than 0. X is 1/2. We should plug it in the original equation, okay? And we will see it satisfy. And number 28. So guys, here, number 28, we can multiply. So the whole one, okay, the whole equation by the common denominator. What is the common denominator? So that is c minus 8 and c plus 5. It's clear, it's obvious that common denominator is c minus 8 times c plus 5. So I multiply these by c plus 5 times c minus 8. So what will happen when I multiply? What will happen when I multiply? Look at here now, c plus 3 times c plus 5, c minus 8, c plus 5, c minus 8 over c minus 8, you see, equals c minus 4 multiplied by this, c plus 5 times c minus 8 over c plus 5. And we can simplify the factors, and we will have c plus 3 times c plus 5 is equal to c minus 4 times c minus 8. Okay. And attention, here again, we have to write for here c must be different than 8, because 8 minus 8 is 0. And c must be different than negative 5. Okay. All right. C is different than these two numbers. And now I have to solve this equation. I have to use the FOIL. Okay. So c times c, c squared plus 5c plus 3c plus 15 equals c squared minus 8c minus 4c plus 32. All right, so yes, c squared plus 8c plus 15 minus 12c plus 32. So guys, since both c squares, I can cancel them. So you can say minus c square on both sides. Now I have what? Let's combine the c's on one side. This is negative 12c. If I add 12c to both sides, I will have here 20c. And if I subtract 15 on both sides, I will have no number on the left side. 32 minus 15 is 17. And from here, c is equal to 17 over 20. 17 over 20. All right. And c is different than 8, different than minus 5, and this is the answer. Okay, guys. It will be very beneficial if you not only watch, but also write down all the solutions. Not on this paper, as you see, we don't have enough place on it, on your notebook. Last two questions, simplify, addition. Basically, we should factorize and then add and then simplify. It's fine. So we have to factor all numerators and denominators. Let me do here quickly. So D 40 and 3. Product is 40. That is 4 times 10 or 4 times 10, 8 times 5. Yeah, 8 times 5 is good because the difference is 3, right? Since it is plus and the product is negative, minus plus 8 minus 5. Okay? 8 times 5 is negative 40. And here we have DD. Okay? And what do we have here? D squared plus D minus 30. Minus 30. 5 times 6, since the difference should be 1, and the bigger number is positive. D plus 5, D minus 5, D plus 6, D minus 5, negative 30 and 1. Here we have D again. So 48 and 14. Well, 12 times 4, but it doesn't work since we need 14, both positive, we know this, okay? 6 times 8, 6 times 8 is 14, D plus 6, D plus 8, and 6 times 8, 48, 6 plus 8, 14, right? And here we have, okay, so we have minus and plus, 48. It's not 12 times 4, but again 6 times 8, right? Since the difference is 2, in this case, not the sum, and the biggest number should be minus. So minus 8D plus 6. Okay. So what is the common denominator here? We have to check it out. Oh my God. D plus 8. D minus 5, D minus 8, D plus 6. Okay, but they are all different. What to do? Hey, check this out. We can simplify the D minus 5s. And we can simplify the D plus 6 at the beginning. It is good. So the volume of the job will be decreased. But, attention, D cannot be what, guys? We have to write here. D must be different than negative 8, 5, 8, and negative 6, okay? Even it's not the equation, we write it. These are the restrictions. And let's continue. So then D plus 8, D minus 8. I multiply the first fraction by D minus 8. Let's do that. D minus 8 times D plus 6 over D plus 8 times D minus 8. I multiply by D minus 8 plus, and this one I multiply by D plus 8, since it's already has D minus 8. So that is D plus 8 times D plus 8. Yep. Paper. They have common denominator. The common denominator is D plus 8 times D minus 8. Okay, their addition, so I have to multiply them, the FOIL method. Okay, D squared minus 8D plus 6D minus 48 plus d squared. Hey, it is d plus 8 squared. I know it is d squared plus 2 times 8 times d. 16d plus 8 squared, 64. And this is the denominator. Well. I have to combine the terms. There are 2d squares. That is 2d squared. You see it? Yes. Denominator is d plus 8d minus 8. Okay. So what do I have here? Negative 8 plus 6 and plus 16, which is negative 2. It's plus 14d. Negative 48 plus 64, that is plus 12. Okay. Ooh, we still continue. How do you see? 2 is the common factor. 2 is the common factor. I have d squared plus 14d plus 12 over d plus 8 times d minus 8. And now I factor it out. D plus 12 and 14. 14, what I did, guys. If it is 2, it should be 70. It should be 70, and it should be plus 6. Okay, so two numbers product is 6 and the sum is 7. They are 6 and 1. Oh, yeah, no more simplification. It means the final answer is 2 times d plus 6 times d plus 1 all over d plus 8 times d minus 8. Hey, how can I write this d plus 8 times d minus 8? So since I factored the numerator to check if they have any common denominator, so I could simplify them. There is no. So I can go back to this as a final answer. 2d squared plus 14d plus 12 over, hey, what do we have here? D plus 8d minus 8. This is d squared minus 4, right, guys? So this is the, what we did, addition or subtraction? Addition. It's number 29, the result of number 29. This most probably, this is a free response question. You should be careful when combining, when finding, when simplifying. And guys, here we have to simplify. So again, find the factors and multiply the first fraction by the reciprocal of the second one, since it's a division. So x squared minus 16. This is what I did here. D squared minus 64 is d plus 8 times d minus 8. Sorry. X squared minus 16 can be written as x minus 4 times x plus 4 over. So what are the factors here? We have, guys, x, 3 and 2, plus 3 and plus 2, times, so x squared plus 5x plus 4. I write it now in denominator. X plus 1 times x plus 4. X squared minus 2x minus 8. I write in numerator. X. I have what? Minus 2x minus 8. That is 4 times 2. Yes, so minus 4 plus 2. What we write, don't forget, up to denominators. X cannot be what? -3. X must be different than -3, -2, -1, and -4. Okay, guys. These are not in the domain. X must be different than. And then this is multiplication. So let's see, is there any simplification here? We can simplify x plus 2, x plus 4, and x plus 4. We have, yeah, no more simplification. X minus 4 times x minus 4, which is x minus 4 squared. And in denominator, x plus 3 times x plus 1. Well, I can write it like this. This is the simplest form is this division operation. And these are the restrictions.